Right, I'm gonna be talking about circles now. Uh, okay, so the first question that I'm asking, uh, true or false, is a circumference equal to a perimeter? And the other question, does the area of a circle equal throughout if the perimeter of a circumference change its shape like a rubber band? Okay, so me on the first question is gonna be true. I believe that circumference is equal to a perimeter. I don't know why they call it two different things. If we are talking about the same subject. Now, the second question probably helpful if to see the circle. Okay, so let's say that you had the circle with X amount of measurements, right? So the circumference, let's say, measures X, right? So Let's see if you change the circumference to a pentagon with the same X measurement. Uh, will the area stay the same uh, from the circle to the pentagon? So would it would it calculate the same area even though the same measurement of the circumference or the perimeter stay the same? And the answer is no, it doesn't stay the same. Um, uh, but it'll probably become obvious whenever I get into it. Um, so here's some other properties of a circle. Okay, so uh, uh, the diameter of a circle will equal the side of a square that is drawn outside, and then the diameter will equal the hypotenuse on the inner square, and the let me see here. Mm, yeah, and then the sides will equal different sides. I forgot how you do that, but just never mind. Um, yeah, that's pretty much one of the properties there. So we're gonna get into what is where I'm gonna be getting into most of the math. So I don't know if you ever gotten the area of a circle. How is that done? Um, I'm gonna do it a different way, uh, just to show that see if you can calculate without going infinite. So if you know that pi goes infinitely to a certain amount of digits, or um, or almost infinite, and it does not repeat. So the digits do not repeat. So pi goes to a certain amount of digits that doesn't is not repeating. So the area is not supposed to be infinite or close to being infinite. So what does that mean whenever you calculate the area? Yeah, whenever you calculate the area, it's just gonna be a tiny amount that's either gonna go over, depending on which number you round up. So that tiny difference makes it whenever you do uh, exponential mathematics, you just keep multiplying pi. It's not gonna give you the same answer because you keep adding the same error either uh to increase or decrease depending on what number, but it's mostly going to increase the error. So like whenever you one of the properties of a circle is that you can infinitely bisect. Basically you can have a radius, you can have infinitely many radiuses and they're not 360, but I'm mostly gonna use 360 because that's what it's using right now. And then okay, hopefully, let's see here, hopefully we can see some of the variables here. Okay, so it's not even going to the same page. Okay, so this is gonna get a little bit lengthy because when I did it, I wasn't sure if I was doing that math right because this is kind of complicated for me because I don't usually do this kind of. I'm more used to not doing sacred geometry. Sacred geometry. This is what you get into more likely into sacred geometry rather than just calculus or something like that. But anyways, so uh like Kepler, I believe, was the one that calculated the area of a circle, and he used the area of a triangle as the base equation, and when you do that, you have to come up with a base times the height, and you can use the Pythagorean theorem, which I used it like this, and then the base is just mostly like the amount of degrees they will go into a circle. So you check the circumference and divide the degrees, and it will give you the amount of base. Because see here, you have the radius here, and then you have the oh no, don't do that. Okay, so you have the radius here, you have the radius there. So that's radius 1, radius 2 gives you one triangle, and itty bitty part of the circumference right there, that becomes the base, because that becomes I forgot, not an equilateral triangle, but a two-sided equal. I mean, two of the sides are equal. I forgot what that triangle is called, but because I forgot it right now. But the base becomes this, so that will give you that amount right there, and then here's this is for to plug into the Pythagorean theorem to, and the height, that's just to plug into the Pythagorean theorem. So c squared is equal to the r, a is equal to the h, and that's going to be equal to the b. So in here we're trying to find out the height, so that's not going to get that confused over here because we're just trying to find out the height from this right here. That's what we're going to do. I probably should have written it differently, but the height, because we got the base, and the base is this, and all we need to do is just figure out the height, because the triangle is kind of curved, so whenever you flatten it out, the degree changes. So whenever you draw an actual, how can I put it, I'm gonna put it in terms that people gonna understand. Like whenever you draw a circle, it's actually you're calculating more for the area of 360 triangles rather than a whole circle, because 360 triangles will make a circle if they're both equal. So when the radius with the circumference gets flattened to become the base, uh, it changes the degrees slightly for to compensate for the decrease in the area of the base, to put it into a more a basically it just gets wider rather than it gets taller. So uh I don't know if, but I don't know if I'm just trying to do this more algebraically rather than get into um into more geometry. But then even though we're doing geometry, but I forgot the area of mathematics you do this. But basically, since you're taking the same proportion and the circumference kind of does not stretch or you don't do anything, it's just gonna make the triangle wider. It's not gonna change like it's not gonna change anything. Whenever you calculate it's just gonna change the height just slightly, because it's not gonna be the radius. It's just gonna be a different height that you use, because you're mostly calculating for 360 triangles. I don't know if I explained that. I know it's a bit repetitive, but I don't know if it's incredibly good uh, uh, at explaining it. Okay, so okay, that's not a good picture. So here's the bottom part. So basically, you get to get the height, you just gotta do the Pythagorean theorem here, just reverse. So the radius becomes square, and then you just calculate for the radius right here, and then it's gonna square up by that. So when you start simplifying it, this becomes that, and then you multiply things out, and then you keep simplifying it until you get this, and that becomes your height. The end part becomes your height, and then you just put it back over here on the top right here, on the top corner, but it got blocked by the little arrows. But and then here becomes your, see if you see it. Okay, so that's gonna become your base, which we put right there. Yeah, just circumference divided by, see, circumference 2 pi r. So you just plug that in there, and then you put 1/2, and then you just start canceling until you get this. And it's supposed to give you the area. And if you change the radius to 1, basically just change the value to 1 right there, it's gonna give you pi. In a regular circle, it just gives you pi. But in our purposes, we get this slightly bigger area right here. So see, whenever you start doing this, it doesn't really give you that much. You only come out with pretty much 90% difference here. But let me see here. Let me think about it. Supposed to not do this. Oh man. 14. Okay, so the gives you pi right here. Pi is this one. Okay, so the one with the P is pi, and then the one with the A is the area of this guy right here. So the difference becomes 0.0019625 and 85 and 89. It's about 99% off. Is it the answer? And I'm gonna go out on a limb and say it's probably not. It's pretty close, but why would I say that it's probably not the right answer? It is because of the degrees. See here, if you calculate for the degrees right here, so you have 360 degrees, so that's going to give you somewhere around 360 triangles, individual triangles in there. So yeah, stop moving. So what does that mean? Well, if you can infinitely bisect a circle, it's gonna keep bisecting. So it's gonna go from 60 to 720. So if all these numbers change, and it's really what it's really gonna do is just gonna be we're gonna go back to I believe Aristotle, or no, yeah, it will probably Copernicus. No, I forgot. But anyways, it's gonna, as you go as many degrees, if you change the amount of degrees here, it's gonna get closer to pi. So it's gonna get closer to pi. So the question is, if the whenever you calculate the area of a circle, see, because I try to do this with a calculator, it still goes on into somewhat of an infinite, but it's supposed to end somewhere. It's just that I can't really, from this point, I can't really do a lot of the math because I'm not really a human calculator. So I know that pi is gonna eventually go and be like be going infinite, but this guy right here is the one that's supposed to be this guy right here is supposed to be ending, and pi is supposed to be going infinite. So you're not supposed to have the same number of digits there. So yeah, there's a difference right now, which I would like to say that it's not really gonna be the answer. Why? The area, because the area of a circle is not supposed to go infinite, but if it doesn't really show, because my calculator just gives you that right there. But why do I believe that if we go back to the second question, why is it not going to calculate the area if you change the shape of the circumference of perimeter? It does not, because basically what you're actually doing again is doing pi again. So basically, like, you can change the circumference or perimeter of the shape that you're doing. In our case, it will be a circle, and keep changing the shape. You can go. The first shape will be a triangle, so it'll be a three-sided equilateral triangle. Three-sided equilateral triangle, and it'll be a square, and it'll be a pentagon, hexagon. So as long as you keep adding the sides, dividing by the sides, it's just gonna keep going to pi. So you can get the area of a pentagon and a hexagon and all that stuff. As actually, I don't really have my notes right now, but I used to have some decent notes back when I was doing it, and I made a couple errors, but it would have been quite nice if I would have just had that notebook again. But yeah, it's a lengthy video, going on to 30 minutes now. But probably from the next video, I'll probably recap some of the problems that I've done right now. Does it help about the area of circle? No, it does not. I think for me, it raises more questions because now I have to double check this particular proof or math right here and try to change the see the degrees here. So if you change the degrees, you change the see here, this right here, the circumference, and ultimately it will change all of this right here, which well, I think it's going to give you more of an approximation of pi. It seems to be going into that direction. I just don't know if it's going to keep decreasing or increasing. But I will get back to this problem in a couple of months. Just think about it, because I kind of had it done, but I was thinking of making a video, but I kind of had done it like 5 years ago. It's been a couple of whiles, but I've just have not done the video on this, and I just wanted to get something to where you can probably see my factoring probably is. I think my factoring is pretty good. So I'll double check my factoring on the Pythagorean theorem part, and I definitely did my factoring really great, I believe. I think at this point I have it really bulletproof, unless somebody is gonna come and say you made a mistake somewhere in there, but no, I think I have my factoring pretty good. So if I didn't have my factoring pretty good, actually the answer probably would have not come out that good. Pretty close to par right there. So I think I got all my properties in it. So the only thing that I wasn't able to simplify was the 360 degrees right there, um, which is giving me a. I think that is raising some questions whether I made a mistake or not. Mm, but I would go back to it and try to see if I didn't make a mistake again, so I can make another video about this subject. And I probably need to make another video about the recapping the other videos, because I don't know if some people are. I kind of don't really think about my words. I don't explain because I'm not teaching math. This is more me just attempting to solve, but I don't have what I believe is an actual solution. I just give you either some equations or what I believe is a number that will appear in because most of it is, I believe most of it is done in the computer, so like a supercomputer. So, and I'll leave this to you guys right now. Uh, yeah, just let me know politely. Thank you. Bye.